Hello there, grade 7 learners. So, how are you doing? Welcome again to our Math O'Clock with teacher Catherine. This time we will be discussing properties of operations on the set of integers. And you are expected to illustrate the different properties of operations on the set of integers at the end of this lesson. This is just a continuation of the concepts on the operations on integers, which you have discussed last time. And mastering the rules in the previous module will help you speed you up in completing this lesson. So are you ready? Okay, let us start with the first one. The first property is the closure property. So closure property states that two integers that are added and multiplied remain as integers. The set of integers is closed under addition and multiplication. So under the closure property of addition for real numbers, it states that if a and b are real numbers, then a plus b is a unique real number. On the other hand, the closure property of multiplication states that for real numbers a and b, the product, which is a times b, is also a real number. Therefore, closure property simply tells us that if we are going to add or to perform any operation among real numbers, the product or the result will always be a real number. Let's have the following example. Okay, so we have here an operation under addition. 15 plus 16 equals 31. 15 is a real number. 16 is also a real number. Therefore, the answer, which is 31, is also a real number. In multiplication, let's say for example, 26 and 12 are real numbers, therefore their product, which is 312, are also real numbers. Adding or multiplying two real numbers produces another real number. The second property is the commutative property. Commutative property states that changing the order of two numbers that are either being added or multiplied does not change the value. Again, the order of the two numbers do not affect or does not affect the process in terms of addition or multiplication. So in symbols, that is given by a plus b is equal to b plus a. Assume that a and b are real numbers. So as we can see, the order changes or are changed. But according to this property, the result will still be the same. Same is true with multiplication of real numbers. So if we are going to multiply a times b and b and a, the order changed, okay? The result will always be the same. So let us try this property in numbers. So we have here in addition, 2 plus 3 is equal to 3 plus 2. Is the equation correct? Okay, let us see. 2 plus 3 is 5. Okay. How about 3 plus 2? Would that be equal to 5 also? Alright, very good. So as we can see, 5 is also equal to 5. Therefore, we have proven that the commutative property or the order didn't really affected the result. We have more examples here. Negative 16 plus negative 5 equals negative 5 plus negative 16. Performing the operation, we will be arriving at the same answer, which is negative 21. Same is true with our number 3 example, which is 100 plus 99 equals 99 plus 100. Whether the 100 comes first or not, we will still be arriving with 199 as the answer. Same property is true with multiplication. Commutative property for multiplication. 2 times 3 is 6, and that is also equal to 3 times 2, which will give us the answer 6. Same is true with negative 4 and negative 15. Okay? And negative 15 and negative 4. So the product is 60. 10 times 25 and 25 times 10 will also give us the same result, which is 250. How about for subtraction and division? Do you think commutative property is still applicable? Okay, let us see. Under subtraction and division, commutative property is no longer applicable. Why? Let us take the following examples. Let's try 5 minus 6 and 6 minus 5. 5 minus 6 is equal to negative 1, and 6 minus 5 is equal to 1. So as we can see, it is clear that negative 1 is not equal to positive 1. Therefore, we cannot apply the property in subtraction. And in division, this is the common mistake of some learners. 2 divided by 4, is it equal to 4 divided by 2? Alright, no, because 2 divided by 4 is equal to 0.5 or 1 half. 4 divided by 2 on the other hand is equal to 2. Always take note of this. They are different, or we have this different quotient for this. 2 over 4 is 0.5 and 4 over 2 is equal to 2. So, commutative property is not applicable. Let us have associative property. In this property, the grouping of numbers cannot affect or does not affect the result. Again, this is only applicable for addition or multiplication. So, in symbols, that is given by A plus B plus C equals A plus the quantity B plus C. The parenthesis that you can see is read as the quantity. For multiplication, we have the quantity A times B times C equals A times the quantity B plus C. In numbers, that is given by the quantity 2 plus 3 then plus 4 equals 2 plus the quantity 3 plus 4. For the checking, perform first the operations inside the parentheses. So we will simplify first 2 plus 3 and 3 plus 4. 2 plus 3 is equal to 5. And then we are going to add plus 4 equals 2 plus 3 plus 4 is equal to 7. Simplifying this, we will be having 9. And as we can see, we have the same result for both sides of the equation. Same is true with multiplication. If we are going to multiply 4 times 3 first, before multiplying it to 5, we will be getting the 60 as the answer. And for on the other side of the equation, we are going to multiply 3 times 5 first, so that will give us 15. Then multiply it by 4, so the answer again is 60. So nothing has changed with the result. But again, subtraction and division are not associative. So therefore, we cannot apply this property or changing in groupings in subtraction and division. Let us have the next property, the distributive property. Distributive property states that when two numbers have been added or subtracted, so you have two numbers added and subtracted, and then multiplied by a factor, the result will be the same when each number is multiplied by the factor and the products are then added or subtracted. So here is the illustration of the given property. The first one is for addition. So we have addition inside the parentheses. And then we have a factor which is a. Distributing a or multiplying the factor a to each of the addends, which is b and c, a times b and then a times c will give us the same result. The second one is for subtraction. So whether you are going to perform the first one or the second one, you will be getting the same answer. So here are the examples. So we have 2 times 3 plus times the quantity 3 plus 4 equals 2 times 3 plus 2 times 4. Let us check if we will arrive the same answer. Let us deal first with the operation on the left, the one with the parentheses. So let us simplify first. 3 plus 4 is equal to 7. Then multiply it by 2, that is 14. And on the other side, we have 2 times 3 plus 2 times 4. Simplifying the operation, that is 6 plus 8, which is also equal to 14. So for addition, that is also true. Same is true with subtraction. So whether you are going to perform first the one with the parentheses, the first one, 5 times the quantity 8 minus 3, you will be arriving at 25. And then on the other hand, or on the other side of the equal sign, we have 5 times 8 minus 5 times 3. So that will give us 40 minus 15. The answer is still 25. So nothing has changed. The next property is very easy, which is the identity property. The identity property states that for additive identity, the sum of any number and 0 is the given number. So this simply means that any number added to 0 will always be equal to the number itself. And 0 is the additive identity. So let us have this one. 4 plus 0 is equal to 4. Negative 10 plus 0 is equal to negative 10. 99 plus 0 is equal to 99. So as we can see, given the three numbers, nothing has changed with the sum. Same is true for multiplication, but this time, 0 is not the multiplicative identity. The multiplicative identity is 1. Okay? So any number multiplied by 1 will always be equal to the number itself. Again, 1 is the multiplicative identity. So 12 times 1 is equal to 12. Negative 32 times 1 is equal to negative 32. 99 times 1 is equal to 99. Okay, this is a technique for all of you. Any number multiplied by 1 is equal to the number itself. Let's have the last property, which is the inverse property. For the additive inverse, it states that the sum of any number and its additive inverse is 0. So the additive inverse, what is that additive inverse? So the additive inverse of a positive number is the negative of that number. Take note of that. So if you are given a positive integer, its negative is its additive inverse. So let's say, for example, number 1, we have positive 9. So the additive inverse is negative 9. And their sum will always be equal to 0. For number 2, we have positive 99. Its additive inverse is negative 99. Again, inverse property, ha? Okay, for number 2, we have negative 58 plus positive 58. We are given a negative integer, so its additive inverse is its opposite, which is positive. Negative 1,000, its inverse is positive 1,000. And if you are going to add them, the result is always equal to 0. Is that clear? Okay, let us try the multiplicative inverse. Multiplicative inverse property states that the property of any number and its multiplicative inverse or reciprocal is 1. So, the multiplicative inverse of the number a is 1 over a. So we will just put it in the denominator. If you are given, let's say for example, a, its reciprocal is 1 over a. Or if you are given a fraction, its reciprocal is just the reverse of it. Just interchange the numerator and the denominator. And if we are going to multiply a certain number and its additive inverse, the product is always equal to 1. So let's have the following examples. So for number 1, we have 6 times 1 over 6. The reciprocal of 6 is 1 over 6. Number 2, the reciprocal of negative 22 is negative 1 over 22. Take a look on the pattern, okay? For number 3, we are given a fraction which is 4 over 7. And its reciprocal is 7 over 4. So for item number 3, as you can see, the numerator and denominator are interchanged. That is how we do the reciprocal. For number 4, we have 5 over 8 and its reciprocal is 8 over 5. The encircled numbers are the reciprocals of the numbers before them. Okay? And if you are going to multiply all of them, the result is always equal to 1. Let us check your reciprocals. Okay? So, what is the reciprocal of 3? What is the reciprocal of 2 over 5? What is the reciprocal of 4? And for number 4, 1/4, what is the reciprocal? Number 5, negative 6. Let us check if you got the correct answer. For number 1, the reciprocal of 3 is 1/3. Number 2, 5 over 2. Number 3, 1/4. 3 over 7, the reciprocal is 7 over 3. And for number 5, negative 6, the reciprocal is negative 1 over 6. Okay, so I guess that this is now clear. You are now ready for our quiz. So identify the property used in each of the statements below. I'll just give you 5 or 10 seconds to do this. Okay, let us check your answers. For number 1, the answer is identity property for addition because we have 0, the additive or the identity property for or identity element for addition. For number 2, as you can see, that is distributive property. Number 2 is distributive property. Number 3, we have commutative property. And number 4, we have identity property for multiplication. And number 5, we have the inverse property. If you got all the answers correctly, congratulations, dear learners, for a job well done. You are really amazing. So we will see each other on the next video. God bless and goodbye.